Hello everyone. Today I'll be taking you through a very important concept in data science, the CRISP DM framework. Along with a simple breakdown of a different data types we commonly work with, I'll be explaining everything using a practical example of bike rental prediction. My goal is to make this session clear, relatable, and easy to understand. It's our first question of our this series of end same paper solution. So let's begin with this. So what we'll cover today? So here what we are going to explore today. First we'll understand the CRISP DM framework, the industry standard workflow followed in data science projects. Next we'll look at a real world example where we apply this framework to predict daily bike rentals. And finally we'll understand different types of data, structured versus unstructured and quantitative versus categorical data. So let's start with understanding of CRISP DM. So basically, CRISP-TM stands for Cross-Industry Standard Process for Data Mining. It's basically a roadmap that helps data scientists follow a structured and disciplined workflow. Instead of randomly jumping into coding, CRISP-DM ensures that every project moves through clear phases. From understanding the business to deploying the final model, it's iterative, meaning we keep coming back to earlier steps whenever needed. This helps build reliable real-world solutions. So let's understand the six phases of it. CRISP DM consists of six major phases: business understanding, data preparation, modeling, evaluation, and deployment. These phases guide us through an initial idea all the way to launching the model in production. Let's discuss about the real world problem here. To understand CRISP DM better, let's look at the real world scenario where we imagine a bike sharing company that wants to predict how many bikes customer will rent each day. Why? Because accurate predictions help the company to optimize inventory, ensuring bikes are available exactly where when needed, improve customer experience by reducing waiting time, schedule maintenance during low demand periods. So this will be a use case we refer to while moving through the CRISP DM phases. Let's discuss towards phase 1 and phase 2, understanding the foundation. The business understanding. The main goal is simple: predict the next day's bike rentals accurately. We also consider factors like weather and seasonal variations. Our success metric here is RMSE, and we aim for less than 20% error. Now, data understanding. Next, we gather historical rental data. This includes temperature, humidity, season, weekday, holidays, and more. We explore the data, find missing values, identify patterns, and understand which factors affect rental counts. Phase 3, data interpretation. Before building any model, data must be cleaned and prepared properly. In this phase, we handle missing values, encode categorical variables, scale numerical features, remove outliers. The output of this stage is a polished data set that's ready for modeling. Think of it as preparing ingredients before cooking. Now, phase 4 is of modeling. Once the data is ready, we start building our models. Here, we choose algorithms like linear regression, random forest, XGBoost, train these models on training dataset, tune hyperparameters for the best possible performance, compare results to identify which model performs the best. And this phase is where the actual prediction capabilities are created. Moving on to our next phase, the evaluation phase. After training, we measure how well the model performs using metrics such as RMSE, MAE, and RT score, R2 score. We ensure that the model is neither underfitted nor overfitted. Only after it passes all these checks do we move on to the final phase of deployment. Deployment is where the model becomes useful for the real world. A deployed model might run as a REST API, be integrated into dashboard, automatically generate daily predictions, get retrained periodically with new data. In short, deployment is the step where insights turn into impact. So yeah, this was the first part of our question one. Now the second part, discussing the difference between structured and unstructured data. Now let's talk about the data types. Structured data. This is a neatly organized data in rows, columns, and clear relationships. For example, Excel sheets, SQL tables, sensor readings. The unstructured data, whereas there has no fixed structure like image, videos, text, or social media post. It's a rich in information but harder to analyze one. Now let's discuss about quantitative data. This is a numerical data, measurable values like height, weight, temperature, or daily bike rentals. And categorical data, it is descriptive, representing groups or labels like gender, city names, seasons, or weather types. Understanding these data types help us choose the correct processing and modeling techniques. Now let's talk about the key takeaways. To summarize, CRISPR-DM gives a complete end-to-end structure for data science projects. Each of its phase ensures we build models systematically. Knowing your data types is essential for choosing the right methods. And finally, combining a strong methodology with proper understanding of data leads to accurate and reliable predictive models. So yeah, that is for this video. Thanks for listening. Thanks for watching. I hope this session helped to understand how CRISPR-DM works